In this lesson, we're going to learn about three things. The Boolean type, which is true or false, variables, and rules for naming them and what they do, and relational operators that test relations between arithmetic quantities. So let's begin with variables. A variable is a symbol that points at an object. All data in Python are referred to as objects. So we can do something like this: x equals sign 5. One thing this is not x equals 5 that you learned in Mrs. Wormwood's math class. This is x is bound to the value 5, or think of x points at the value 5. Now, if you type x, it will echo back what value it's pointing at. If you type an expression involving x, it will evaluate that expression by substituting in the value 5 wherever Python sees an x. You can create as many variables as you want. Here, let's create another one, 6. Now, one thing that's interesting to see is, what are all the variables you've created? Well, if you type dir in empty parentheses, you'll see a bunch of stuff surrounded by double underscores. What are these things? They are Python's language infrastructure. At the end of that list, and those things are going to be things that are visible throughout the lifetime of your program. But at the end of that list, you'll see user-defined variables. That you see x and you see y. Okay? So this is where the symbol table is stored. A symbol table is just a dictionary whose words are variables and whose values or definitions are things pointed at by those variables. Now, here's another thing we can do. We can compare. So far, we have only really one type, the number type. But we're about to see the Boolean type. Because if I go x is less than y, because 5 is less than 6, that's true. How do I test for less than or equal to? Well, in the obvious way. Can I reverse inequalities? Yes, greater than, and that's 5 is not greater than 6. 5 is not greater than or equal to 6, so therefore I get a false. True and false are the two Boolean constants. They are as legit a value to type in as a literal as a number is. So numbers are literals, they are data, and true and false are data. Now, what are the names? So let's talk about the rules for defining a variable. Let's talk about the rules for defining a variable. Then we'll talk about equality next. Okay, the rule is very simple. I'm going to type a pound sign, which is just a comment. It's ignored by Python, but it allows me to make notes in here. Or if you're writing a program, it allows you to make notes to yourself or another programmer you might be working with. So I'm going to say pound sign, just to turn the interpreter off for a moment. And I'm going to say the first rule for variable names is the first character is alphabetical, or an underscore. That's this thing here. All right. Then, rule 2, subsequent characters are alphanumeric, so they can be numbers as well, or underscores. Now, one thing I should point out to you that's really important is Python is case sensitive. I shall demonstrate that here by deliberately creating an error. If I say A is equal to 6, and then I type capital A, you'll see Python is saying, I've never heard of capital A because Python is case sensitive. So there is a difference between lowercase and uppercase letters. Variable names that you've seen here or so far have only been one letter. But when you're actually writing a program, it's useful to write variable names that are evocative of the purpose of the data being stored. Here's an example of a variable name being done in underscore notation, which is the preferred means of separating words in Python. You cannot put a space, because a space is not alphanumeric and it's not an underscore in a variable name. So if I say number of children is 6, there's a variable set up and it says number of children is 6. Sometimes you'll see programmers do this instead, which is more common in Java programming. You could go like that. That's called camel notation. And the reason for the name camel notation is that the capital letters are kind of like humps on a camel and they set things apart. Okay? So now we know about variables, rules for naming them, and we've met 4 relational operators. Let's meet the other 2. The other 2 are this. One is this is equal to. You can say that all in one word. Okay, that's how I think of it. That's the is equals to operator, and the not equals operator is done by doing bang, and I use bang for exclamation point. Bang equals 5. False. Okay, so that's checking for inequality. Now, let's talk a little bit about the Boolean type, because the Boolean type has some interesting properties and operators. First of all, there is a prefix unary operator for the Boolean type that I should introduce. Not reverses the truth value of a Boolean expression. So not true, false. Not false, true. So this is a prefix unary operator. Unary meaning it has one operand. There are 2 infix binary operators that are also applied to Boolean expressions, and one of them is and. So we'll try all 4 possibilities. True and true, true and false, and we'll get a sense for what and does. False and true, false and false. So what do we see here? If you have 2 operands, and is only true if both operands are true. Now, one thing that happens with and is short-circuiting. If the first operand is false, then the second is never seen. It's ignored entirely. That's called short-circuiting. And that can be useful and can protect you from having untoward things happen. Be aware that it exists. Now let's talk about or. That's the second infix binary operator. So I'll say true or true. True. Let's try true or false. Let's get rid of that nasty little error there. All right, true or false. That's still true. False or true. And then finally, false or false. That one's false. So if I have P and Q that are Booleans, when is P or Q true? It's true when at least one of P or Q is true. And there is a form of short-circuiting here. If the first operand is true, the second is ignored. because we know that if one of the operands is true, then OR is true. So the second one will not be visited. And again, it may be a way, as we go along, of protecting certain things from happening that might generate an exception. And we'll point these out when we get there down the road. So today what you've learned about is relational operators for numbers. Less than, greater than, less than or equal to, greater than or equal to, is equal to, not equal to. You learned about Booleans. Now, here is a problem for you to try to resolve. What is the order of operations for Booleans? How can you answer that? Well, perform some experiments. You can, just as with numbers, override the order of operations using parentheses. So fiddle around with that and see who sticks first, not, and, or. So that, I think, will suffice for now. See you next time.